Yes, I'm hoglahoo on Eterna, and I'm joining you from Tulsa, Oklahoma. And I came to Eternacon last year, had a lot of fun. And now that I see you guys in the conference room and saw the lab walkthrough and stuff, I kind of wish I was there, but just didn't work out this time. But it's cool to see everybody. I don't have a slideshow. Kind of what I want to do is explore kind of what got me over hump in puzzle solving when I started playing Eterna. And it has to do with basically how shapes get folded. And so I just want to look at single state for now, and in the original energy model, Vienna, I don't know which one it is, 1 point something. So I'm just going to be using that. What I want to do here is turn on these energy values. Okay, so I had kind of a hang up when I was probably a month or two into playing the game. And what would happen is, see, I kind of had the idea that a puzzle would solve whenever the target energy and the natural energy were both the same in both modes. When target mode equaled natural mode, then the puzzle should be solved. But there are some shapes where the target does not match the natural, even though the energy is the same. And I just couldn't get past that. It was a huge mental stumbling block for me. In fact, let me see if I can recreate that here. Okay, and I don't really plan to go through boosting. I think probably most people at Eternacon knows about that. So let's look at this. Okay, so down here, I've got this shape that it opens up in natural mode, but in target mode, it's closing. But up here in the corner, in the upper left corner, you look at the total energy value, and the energy value is the same. And so that's what was hanging me up. I thought, well, it should always be equal if the puzzle is solved. But the puzzle's not solved. And what I didn't realize was that there are so many natural mode shapes that can appear, and the target mode, the sequence that you use in target mode has to produce an energy that's lower than all other possible shapes that sequence can fold into, according to the model. And so what he kind of explained to me was you just lower it a little bit, just lower it a little bit more, and you'll get it. And I thought, well, okay, so, but why does this work? How does this happen? And what kind of does it for me is you've got right here where this is opening up, there's three main components here. There's this stack, which I've highlighted. I hope everybody can see that. I think I'm zoomed all the way in. And this stack these are called quads, I believe. Got these two quads in here, and these two quads add up to a negative 2.4 kilocalories, kcal. And then the hairpin is 2.5. So the total for this branch, the total kcal for this whole branch is 0.1 kcal. That's all it provides. That's all it adds. Now you look here in the middle at this multi-loop, and you have 1.6 in target mode. In natural mode, when it opens up, you got the 1.7. So when you add these, the 1.6 plus the total 0.1 for this branch, you get that same 1.7. So that's where the equality comes in. And so there's kind of been some debate over how the model chooses which shape this sequence should fold into, because by all rights, either one should be preferable. And I guess by theory, if the model was perfect in lab, then you would see about half of the sequences shaping up like this and half of them shaping up like that. So if you just nudge the sequence a little bit more in the direction of the shape you want, that's what it'll stick in. And I'm going to try to apply this concept in an older puzzle. I'm kind of let me go ahead and finish up here. Okay, yeah. See, here's another example. Just to kind of re-illustrate this, over here we have the exact same shape, exact same problem. It's the exact same sequence. You add them up, and it's the same. And so the question here is, well, why does this one fold? And that's a question no one, as far as I know, has quite been able to answer. Why does this one down here work and the other one doesn't, when it's the exact same energies? I guess that's kind of an aside. Okay, this is a puzzle called Simple Single Bond, and this was created by Starry Jess in order to help solve one of Broad's evil puzzles. And what we have is, I'm just going to throw in a bunch of GC pairs. This is kind of how I start most puzzles. I just slap in a whole bunch of these GC pairs. They're strong. Just lost my mouse. They're strong, so I don't have to worry that I'm not creating enough strength to be able to close the shape if I were to start with a bunch of AU pairs or GU pairs. Go ahead and boost this loop. Okay, now I've still got this instability here in the middle. Oh, and by the way, please stop me at some point if anybody has any questions. If I'm going too fast. Have I already lost a bunch of people, or is it like going too slow? Is it too easy? Okay.
Does everybody here feel like the pace is going good? Okay. Yeah, the pace is going good here.
Okay. All right. So when I'm troubleshooting a single bond, or almost any, whenever I see red up here in my stability area and it's only one area or one pair, I'll just go ahead and look at the natural mode and the target mode and compare them and see what's going on. And the main thing I look at really anymore in determining how much work I have to do to close this bond is I look at the total kcal up here in the upper left-hand corner. I don't really need, this precise specific value is not quite so important to me. It's the difference between this total value and this total value. I've got to somehow make up that 3.13 kilocalories that are missing in order to bring my energies back into sync. And so I know I can boost these loops. And so the traditional way to boost is you got an A on one side and a G on the other side for an internal loop. Same over here. And so you see my target mode energy dropping, which is good. It's not dropping enough though. And part of the problem here, okay, there's one other boost. Okay. This is as low as I can get this puzzle to be. Okay, that's as low as I can get this puzzle to be. I can't boost it any farther. That's as good as I can do. So, and I think probably some of you, maybe all of you, already know what to do here. But does anyone have like an idea? Why can't I just keep going lower, right? Why can't I just keep bringing the target mode shape lower in energy? I think the problem what's tough to look at here is you kind of have to get your mind out of just the target mode and look at the natural mode. And you have to look at this as its own puzzle over here. And it takes a lot of practice in working other puzzles to see what's going on. But here we have a GC pair turned like this. Okay, to explain it maybe a little bit more clearly, I'm looking for what can I change in the target mode that will also change the natural mode differently. In other words, all these bases I'm highlighting, those are the same shapes in both modes. So it's pointless to play with those right now. And so I can focus on these two things, this quad here and this minus 1.9 open loop energy. Those are the main two things. And so what I want to look at here is what affects that. Both, I'll go ahead and highlight those things over here. The only bases here that can change this energy are these four. There's no other base. I can't make any other mutations that can help me or hurt me in this mode, natural mode, in this shape. Nothing else makes a difference. But changing these will make a difference. I'm going to put this in Puzzle Maker just for a second. So we'll stop doing that. Okay, so if you watch the natural mode energy up there, in the open loop, it's minus 1.9. Now it's minus 1.4, minus 1.2. Any changes I make here can potentially bring up a change in that energy. So that's the kind of thing I want to look at, is changing these. All right, so how do I know what I want to change? Let's go back to the actual puzzle. I guess I could have just reloaded the page. Okay, so I want to focus on these right now. You might say, well, what about these over here on the right? Why not those? Well, like we just showed, I can change those, but I've already got them. I've already turned these in the lowest possible energy configuration right here, and it's not good enough. So if I keep changing it, it's not going to bring this down. I need to bring this number down because I've brought this number as low as I can get it. So I need to make this more. Need to make this number more less negative. I hope that makes sense. Okay, so what I want to look at here is what's this dynamic here, this GC pair. Over here in target mode, I've got a GC pair that's closing an internal loop. And over here, it's a GC pair closing an open loop. So I want to show what the difference is over here between a GC pair closing an internal loop and a GC pair closing a multi-loop. And this is something I've used many, many times to help learn how this model works. And of course, as it relates to lab and other puzzles with other energy models, the various numbers change, but the basic principles still apply. The basic troubleshooting logic still applies. You can still look at these and say, hey, what's more efficient in a multi-loop? An AU pair or a GC pair, assuming you have enough energy to actually close everything else. And so what you can do is look at this. Just for example, a GC pair turned this way versus an AU pair turned this way in the open loop. Bear with me. I'm going to try to make this clear. Look at the difference between the energy of the multi-loop when I have a GC pair and the energy when I have an AU pair. It's pretty big. It goes from 1.5 to 0.2. So that's a 1.3 kcal difference. Compare that to the internal loop. I'm going to change this one now and see if there's a bigger difference or a smaller difference. Okay, so the internal loop is 2.7 with an AU pair closing it, and it's 2 with a GC pair closing it. So the way I like to look at this is to say, if I only, let's say it like this. It's much more helpful to fold a multi-loop or an open loop by using a GC pair, because there's such a big difference between using an AU pair there or a GC pair there. Huge difference. In an internal loop, the difference is not so much. I don't lose as much energy that way. And the way I want to apply that here is by looking here at this mode right here. Right now, with this GC pair sitting here, I'm greatly helping this open loop fold. I'm encouraging this open loop to come open. And when I look in target mode, I have a GC pair, and I know the common wisdom is, hey, put GC pairs at the end of stacks. They help close loops. Well, that's true. Every pair helps close loops most of the time. The question for me is, which pair helps it close better compared to other shapes that want to form? And in this case right now, since this is the other shape that wants to form, I need to use a pair that is less helpful for the open loop to form, and yet not so hurtful to this internal loop. So let me use an AU pair. Okay, and now my difference in energies between target and natural mode has closed. I've closed quite a bit of it. My target mode energy is minus 5.87, natural minus 6.1. It's a fraction of a kcal. And just a minute ago, when I was using this, it's almost a full kcal. So I made up about 3/4 of a kcal by doing that. I know it seems small, but that's basically how to solve some of these tougher ones where you have to get into the details of the model a little bit and figure out what to do, figure out how to close this thing. Okay, so I'm still having the same issue here. It doesn't matter which way I turn this AU pair, I still can't lower my target energy. That's kind of my default. I try to lower the target energy. I just keep trying to lower it until I get below any other shape that can fold. That way, I'll reach stability. But in this case, I've still got this pesky open loop coming up. I feel like, okay, let's look at one other possibility, the GU pair. Just as a matter of course. Okay, I've got 2.7 in my internal loop. No matter which way I turn it, I get the same with the AU pair. So there's no difference in the internal loop having a GU or an AU. And all internal loops that are bigger than this size, 3x3, they all behave the same as far as what pair you choose to close the loop with. As far as the energy difference between GC and AU and GU. Up here, GU pair, 1.5 and 1.6 in the multi-loop, same as the AU. My point here is I can't lower the energy anymore by changing this pair. This is the best I can come up with. Which way do I want to turn it? Well, as you can see, flipping the AU pair doesn't change the internal loop energy. So it doesn't matter for target shape. I can turn it any way. So now I want to look at natural mode and see which way hurts the multi-loop more. And that's the way I'll turn it. I want to keep discouraging this shape from forming. Okay, minus 0.6 here, minus 0.5 here. I'm going to go with the minus 0.5 for now and just have it turned this way. So I'm coming really close. I don't have the only other two bases now that will help change anything are these two. Nothing else is going to no other bases are going to make a difference in this puzzle. I hope I've made that clear and not made it too muddy. Okay, so the same general concept is going to apply here. I can do lots of things with these two bases. The ideal thing is to lower the target energy of the internal loop and raise the energy of this open loop over here. Now, to lower the target energy of the internal loop, I have three options I know of. I can have a G here and an A here, or I can switch those. And those both give me the same energy, 1.63. I can also do the UU, which gives me 2.03. Nothing else I try will get it any lower than an AA mismatch. There's nothing else will lower it in this energy model. So those are my options. So when I come over here, I want to look for something that's going to raise this energy. And my three options were this. I could have a GA, that gives me a minus 0.5. I could have a GA this way, that gives me a minus 0.6. Or I can do the UU. Put this in Puzzle Maker again, so I don't spoil the ending prematurely. Okay, if I do a UU, now this open loop energy, if y'all were watching, it went from minus 0.5 to 0.2. That's a huge jump. Huge jump. Now, what's important to me is it a bigger jump than it would be in the internal loop in the target mode? That's what's important. Is it enough to overcome the difference that I had to begin with? Get rid of those for a second. Okay. So the internal loop gets boosted by, let's see, how much does it get boosted by? 0.7. Okay, this looks good. That's my natural mode. Okay, so I think all I have to do now is boost this internal loop. I've got a misfold over here, but that's pretty trivial. And that's it. Someone in chat, having a multi-chat screen share with just a chat communication with multiple players, all within Eterna, would be great for tutorials. I kind of agree with that. We've done that in the past. Actually, a few different people have used TeamViewer and a couple of other screencast programs to do live walkthroughs with people. They can chat and see how people solve puzzles. It was kind of fun. I think it's been a while since anyone's done one like that, though. Okay, so here's something else that's interesting. If I turn this AU pair this way, it doesn't solve anymore. And the reason for that is back over here. Make this the target shape. There we go. Okay, the reason for that, if you look at the open loop energy, big difference now between flipping this AU pair, minus 0.3 and positive 0.2. Without those two U's there, the difference is negligible. It's only 0.1. So there are a lot of tricky things in this. It's a deceptively simple looking puzzle, but it's really tough. It's really tough to know, like, just for example, to go back to Ben's presentation on the puzzle progression, we have a couple of puzzles where you have to use this UU mismatch in an internal loop in order to solve the puzzle. And nobody who's new knows why you have to do that. And this is the why. And I think you have to have like some kind of a walkthrough tutorial, or else you just have to get in there yourself in the puzzle maker and really dig through all these possibilities in order to find out how you can stabilize a shape like this. What some people like to do is, go back to target mode. In fact, what a whole lot of people do when they're creating puzzles for publishing, player puzzles, just to make them fun or interesting, and to make them, to kind of test yourself. Puzzle makers, if they're trying to push themselves, what they'll do is they'll keep making a shape more and more difficult to solve, and they'll do it gradually. See, for instance, right here, this is solved. And so what a puzzle maker might do is just nudge this loop open a little bit. It increases the energy just a tiny bit. And just by messing around, you figure out, oh, hey, I found another way to do that. I didn't know about that before. So you make a loop a little bit bigger. It's still solved. Let's make it a little bit bigger. And you keep going bigger and bigger until you get something where that sequence doesn't work anymore. So you try something else. Okay, that worked. And so by using Puzzle Maker, that's the way the pioneers, I think, of some of these more difficult puzzles that were made years ago, that kind of pushed Eterna beyond just the really simple fold a stack, fold a loop, like most of the challenge puzzles are. That's kind of how you can learn without a tutorial or without a progression to learn how the models work. But a tutorial will get you past a lot of that trial and error really quickly. And there's I think I mentioned the Catalyst Points post in the forum explains this specific puzzle and tries to explain why this works. And I think, if we did have some walkthrough tutorials like that to go along with the puzzles and the progression, that would be really good for those people who are like, I don't know why this solved. I would really like to know why. Not everyone wants to know why. They just want to get on to the lab. And that's, that would be, to give people that option to either just keep speeding along or to slow down and kind of dig deeper into it. I think that would be pretty cool. I'm looking for questions in the chat. I see some people talking. What about an option to render natural and target mode tiled like you can for switches? Yeah. Everyday 847 brought up a good question. And that's I was talking to Riju recently, and I mentioned that kind of like what this guy in chat just mentioned, is kind of a good way to think of single state puzzles. When you have a problem like this, why not just make it a switch and think of each state as a separate state? That way you see both at the same time, and you can more clearly see what's going on. You don't have to flip back and forth and try to remember, oh yeah, what was I looking at over there? I mean, we do have the highlight bases, but let me just demonstrate what I'm talking about. Okay, so I've recreated that puzzle as a switch. In fact, this is probably how I should have done the presentation. Anyway. Okay, so here you can see that, this is kind of what a tiled view would look like for Everyday 847 in chat, who was asking about that. And I think that would be pretty cool. It would have to look a little bit different, maybe. You wouldn't want to get confused and think that this is a switch, but a switch puzzle where you have to solve both states. But anyway, Does anyone have any questions? There's only 10 minutes left in my slot. I kind of wanted to look at a switch puzzle and just kind of go through the simple steps that I use to solve. But if we just want to take a few minutes for questions and maybe have a short break and maybe give you a longer lunch, go ahead.
Yeah, so we started a little bit late. We're running a little bit behind, so it's fine if you continue on. We'll go to lunch a little bit late if everybody's okay with that, to
okay.
learn some more stuff.
Give
another 20, 30 minutes.
That's what we'll do.
Right.
Okay.
Oh yeah, lunch is being delivered too, so we'll eat when we get here.
You're delivering a lunch to me? That's great.
No, the lunch is it's being airmailed. No, it's we're gonna get the lunches delivered, and we'll figure that out once I get here.
There is one question in chat.
Oh, yes. Thank you. Why do boosts favor being in a lower position in the puzzle? Consider the for loop GAAA versus AAAG. Yeah. Okay. That's a tough question. Okay, so I think what you mean is like, why is this a higher energy than this? It looks equal, right? I mean, just looking at it from a shape perspective, it seems like they should be equal. And I can't give you the scientific explanation there. All I can do is tell you that I've been told, and if I've learned anything in the past few years being on Eterna, that these sequences in nature, they're basically a string, and this string starts trying to fold from base 1, and it ends around base 57. Ends at the end of the string, and so it's like it's coming this way, looking for folds as it sequences. And you guys stop me if I'm wrong. This may be a horrible way to show it, but there's a directionality, in other words, and so the lower base is treated differently than the higher base, even though it looks the same, and I think that's because the sequence folds from the lower base numbers first. So since it runs into this base first, nature treats it differently. That's the best explanation I can give. Okay. So the switch puzzle. This looks straightforward. If anyone has a switch request that might not take too long, I could do that, but I think I might just pull one up. Okay. Yeah, Riju says G AAA and AAAG really do look different in 3 dimensions. Yeah, I'd kind of like to see that. Okay, that one had locked bases. I don't want to do that one. All of these FMN puzzles did. Okay, let's go to... Astroman, are you suggesting a switch puzzle? Okay, I'll try that one. I was just looking through mine because I didn't want to give away one that anyone else has done, but this is a tutorial, so I don't think Jay Nicole would mind. Jay Nickel. I always mess up the pronunciation. Okay. What is my reset shortcut? I always work these things in split screen. Almost always. I start out that way. Okay, so the first thing I like to do is I look for shapes that are the same in both states. And I'm not sure there are any in this one. Usually there are. Just for example, these three bases, they both appear on the outside of an open loop in both states. So I'm probably never going to have to worry about those. And if I had a branch coming off of this multi-loop, if I had a shape that was the same in both of these states, I would just throw a whole bunch of GCs in there right away to lock it down and say, okay, I'm done with that part. I never have to look at that again. Switches can be so confusing. I'm trying to reduce complexity as quickly as I can and make things simple. And so I'm also looking for locked bases, actually. And in fact, Astroman, I am going to go back to that FMN sanity puzzle, if I can find it again, because it has some locked bases, and that would kind of help illustrate what I'm talking about. Okay, all right, now here it looks like I have some shapes that are the same in both. I'm going to go ahead and nail those down. And a good way to check is just throw in a bunch of GC pairs. If you see it pop up in both states as the exact same shape, then yeah, just leave those pairs there. Looks like I've got the same thing down here. So now, in one fell swoop, I've reduced the complexity of this puzzle to two main areas. In the left side state, I've got this little branch, and in the right side state, I've just got this branch. So I'm only going to focus on these areas. The next thing to reduce complexity, I'm going to look for bases that I have to mutate to certain specific things, or else the puzzle can never work. And locked bases that are in base pairs is the first place to start with that. So I'm going to start here with these. It should be fairly obvious. These need to be base pairs. I've got to put a uracil with this adenine. It's the only thing I can do. And over here, I almost always go with GC before I'll do GU whenever I'm starting a switch puzzle. I know in order to switch, I might need GUs eventually, but if I throw GCs in there right away, I'm killing a lot of potential mispairings in that state to begin with. And for me personally, I feel like that also helps reduce complexity a lot of the time. Okay, so I've got the locked bases over there taken care of. I don't care about these in the state on the left, the unbound state, because they're not paired up with anything. They're not forcing me. They're not forcing my hand. Okay, and over here, I don't have any locked bases forcing my hand either. So now what I have are these four. I've got to make pairs out of these. So I'm highlighting them so I can look over here on the unbound state and see what that will affect. I want to see when I start making pairs over here, how is that going to affect this state over here? Right now, this state is stable. This unbound state is already stable. And I know that if it becomes unstable, I could boost this loop. So I'm really not worried at all about this state. It's so strong that I'm just going to throw in some bases over here. I think I'll look at my energy too. I only need 5 kcal lower. Let's just throw in some bases and see what happens. There's not always a rhyme or reason to how I do this. I might just try that. Try something I know will make the bound state stable and see how that affects the other state. I know that this is probably too strong. But once again, when I'm switching really fast back and forth between natural and target, I'm looking at the value of the kcal up in the upper left-hand screen, the total, and I'm looking at the difference. And I'm seeing I've only got a 1.5 kcal difference between target and natural. So I really don't have to make any major changes. I mean, just by comparison, a base pair quad can go from minus 3.3 to minus 2.1 just with a change of pair. So I could make up a lot of that kcal difference just by changing one or two pairs. So I'm not too worried. So I think what I'll do is I'll just keep weakening this bound state, and maybe that will take care of my problem on the left. And it did. That's all it took. Now that was a pretty simple switch. Okay, I've got a question in chat. How much of an energy difference are you looking for from natural and target? Well, I'm looking to minimize it. Once the puzzle's solved, my energy difference is 0. So that's kind of what I'm driving at. If I have, and it kind of depends on how big the puzzle is and how many misfolds I have. If I only have one pair misfolding, and it's a really, really big kcal difference, I know that I can't just flip a bunch of pairs and expect it to solve. I need to look closely and see exactly what's going on. If it's a very small energy difference and it's a misfold, it could just be, need to flip a few things around in terms of switch states. Okay, the state with the molecule. Yep. So let's go back to GC. No, let's go back to this. Okay, I'm just going to put this in here. LFP6 asks in terms of switch states, what kind of energy difference are you looking for between natural and target? Right here, see, I guess the fundamental way that switches work in Eterna, if you don't have this big glowing thing, this puzzle will never solve. You can't have a single sequence solve. You can't have it stabilize two separate states. Eterna just doesn't allow it. So we've got this bonus energy in here, this this minus 4.86 kcal. Whenever this internal loop is bound, I get that bonus. So to answer your question, I'm looking for an energy difference that comes close to this minus 4.6. And right now, what I've got is minus 17.4 and minus 23.1. That's a difference of 5.7. So I'm really not very far away from a solution right here. All I need to do is strengthen this stack a little bit, and I should get a solve. All right. And that's very close to a solve also on that other side, on this state as well. Very close to stability, the energy difference. Yep, just clarifying that. Sometimes you get into a little bit of, you might have in a lot of difficult switches, you're going to have a lot of options. And something you kind of have to look at sometimes is you have to bear in mind other bases like this boost point here. Like, for example, maybe I have to use a GU for some reason. I can keep this G in my back pocket, but I have to bear in mind that if I want to use this as a G at some point, maybe, if I want to do that, then I'm going to have either a U or a C right here at base 15. And so sometimes I'll start my troubleshooting that way. I'll just go ahead and throw in a GC or a GU or an AU, just knowing in the back of my mind that gives me more flexibility. If I need more strength over here later on, I can get it, and it doesn't throw off my my pairs over here. Now, if I were to start that the other way, with it turned like this, I'm never going to be able to get a good boost out of this tetra loop in the unbound state if I have a uracil right here at base 41. And so I might find myself kind of limiting my options. So you kind of have to look for ways to keep your options open and simplify the puzzle. That's just kind of my general thoughts on solving switch puzzles. Does anyone have anything specific or any questions?
don't have any questions here right now.
Okay, well.
Hold up.
Okay.
Hi, this is Riju. I had a question for you.
Sure.
I think it's really what you've described is how important it is to understand the idiosyncrasies of the energy model in order to solve the hardest puzzles. And some of these idiosyncrasies that are as you know, in the folding engine, in the current energetic model, are probably errors, experimental errors. And so
yes.
There's a prospect of remeasuring these energies quite comprehensively, both through new tools that we're developing at Stanford, but also actually we now have Eterna data on millions of switches that fail and work, and we have their KD measurements, and there are folks in my lab who are trying to recalibrate the energy model based on these millions of data. So here's a question. Suppose we released a new energy model in Eterna. How long do you think it would take you and the community to achieve this level of understanding of its idiosyncrasies? Like, is it when Nando released the new Vienna 2 model or the new PAC model, is it sort of a one month and everyone solves 100 puzzles, or do you think you can only gain this appreciation over after 4 years of Eterna mastery?
Well, yeah, it's a great question. I don't think it takes long. As soon as these were made available to us with Puzzle Maker, and I don't remember exactly how this happened. I don't want to put words in anybody's mouth, but I think some players got a preview of these a long while back, and we started making some right away just to play with, and it was a lot of fun. And as long as it's fun, I think it's just a natural progression for people to start rediscovering these things, rediscovering how these other models work. And the very first things I think everyone kind of confirmed just within playing one or two puzzles is that the same basic things work. In these other models, you don't have unpaired bases far away from pairs that affect the energy. That's the same in all the models we have so far. So that's just one thing we noticed right away. Quads, loops, everything seems to behave the same. It's just that the numbers are a little bit different. Some boosts are not as powerful as they used to be, or in models, some boosts are more powerful than others. And I think you find that out really quickly. It doesn't take long. Even if you've only worked maybe 50 puzzles going through the progression or through the challenges, even if you don't know exactly what you're doing, the brain just starts soaking up patterns and thinking, okay, keep doing what was working before. I don't know why it's working, but keep doing it. And when you get a different energy model and you see a pattern suddenly not work that always works before, you think, oh, what happened there? And with a few clicks, you find out, oh, the behavior is different here, and you explore it. And anyone who's interested in creating puzzles or solving difficult ones, I think they'll find that out really quickly. I don't think it takes so long. What takes really long to make progress, I think, is for a player is when there's not much incentive to push forward, or they feel like everything that can be learned for them has been learned. Maybe they feel kind of stuck or burn out on just doing the same old thing over and over. And then they might not be, it might take a lot longer to ever discover something new because they kind of, have a mental block about it. But I think I think as to your original question, I don't think it takes really long to discover those things.
So that's an exciting answer, because I think when we remeasure these parameters, the bases you've highlighted on the screen, they are going to matter.
Okay. That's really cool.
And so I was anxious that would be a turnoff because you'd have to really figure out new stuff. But based on your answer, it sounds like that would be fun to go figure out what the new concepts are, right?
for me personally, yes, it'll be a lot of fun.
And
Partly that's because, yeah.
Well, and then we can have lab tests of single structures after that.
Sure. Yeah. Players who have been playing, I think players who have been playing really long might appreciate it even more just because everything has been the same for so long with the models we have. But even new players, I think, just starting from scratch, it's no more difficult to pick that up than to pick up anything else because people come into it with a blank slate pretty much.
I have a question. Have you ever tried just tweaking either the temperature or the salt concentration of these, and then because that would affect them in the same way, and you could even do that right now and say, okay, here's a thermophiles RNA or something like that. Now, and that stuff is already around, and that would be the beginning of saying, well, these rules are, they're fluid depending on the context and the measurement. And that would be maybe, just changing the temperature, because that's a really easy thing to change in the program. And then if that was a user.
That's a really cool idea. Actually, in Eterna, you guys don't know this, but when we were designing the game, we originally were going to make the game so that higher levels had higher temperatures. Or within the puzzle, we'd steadily increase the temperature, and you would have to mutate the sequence like in real time to keep it stable. Then we decided that would be too stressful. But it's a cool idea. And then also, as you said, in the lab, we can vary the temperature as well. It's an interesting idea. My sense is that these thermodynamic parameters are going to be even crazier and further off away from 37 degrees, where where most of us, the expert labs, have been focusing their attention. But again, I think there's a future coming up fairly soon where we're going to, I think, really understand these numbers at different temperatures and different salt concentrations.
And stuff like that.
Yeah. Oh,
biological
yeah.
Thing that changes RNA.
That's right. Right. So I think Todd is alluding to another idea. We could actually have switches that are switched by temperature. Imagine that kind of puzzle. But those really appear to exist in nature, and the question of how to design them is basically unsolved.
All right. LP6 has something to say.
I thought, just for the benefit of everyone in the room, I know Riju didn't notice it. WH Bob brought up a very good point in chat. He said, puzzles give immediate results, but labs have a longer delay. Speed of feedback is important when learning. And I think that is a good point. And while we're looking at this, I think it is important to consider, like, a lot of this, I think personally, a lot of this, the discrepancy between puzzles and labs is that with puzzles, that with the standard puzzles, you're trying to solve it, in the interface. But really, a lot of what we're trying to do is seeing how it will actually, work when we actually synthesize it. So how can we, make up for that in how we present the game? Again, that's something I wanted to bring up tomorrow, but just some food for thought. Because I know hoglahoo, I'm not sure how much you participate in labs, but I'm assuming you spend a lot more time within the puzzles themselves.
Yeah, in the past, when labs, when the switches first came out, was about when I started playing Eterna. So I was in labs quite a bit for a while, but what WH Bob said kind of discouraged me a little bit with labs because I didn't get immediate results. And back then you have to wait weeks. And that was just, it was just difficult because I think I do all these things, and when you're playing puzzles, you just get it back so quickly. So no, I don't play the labs as much. Of course, we've improved on that a whole lot. You guys get this stuff back really quick now compared to before, and we have so many that we can do. I think that has changed. We get a lot better feedback, but it's not instantaneous like we have in the model.
Yeah, but I think that just from your presentation, you've given us a new idea. I think there is a prospect so that after every lab, we would update our energetic model. Like that, that isn't quite working yet. That computation is hard to do, to take all the lab data and then update the energetic model. It's sort of like a deep learning problem. But if we can get that going, then the labs might take, a month between labs, but then folks could explore the model and set puzzles for each other on a very fast time scale, hours or days in intervening months, to say, oh yeah, the lab model for three-way junctions, or sorry, our energetic model for three-way junctions just got updated because of the July 2016 lab results. Let's see if we can explore that model through new puzzles. So that's, I mean, it's just a vision that we hadn't thought of before. At least I hadn't thought of it before I saw your talk.
Yeah, that sounds really cool. I like that.
Since getting immediate feedback there's a real premium on that, what about freezing the structures and letting the user change the rules to fit the data? And that would be a different kind of puzzle. Okay, everybody mess around with these rules and get them to match these discrepancies. And I'll bet you could get some pretty serious parallel processing. Talk about that now. Yeah, so, you want to comment? Talk about it last year.
Yeah, that sounds really clever.
That would be really fun, actually.
Yes, I think I implemented the potential for changing the parameters within the game. So we could, I think I did the experiment once of loading the Andronescu 2007 parameters with the Vienna 2 engine. It worked. On the fly, changing all parameters is going to be a little bit confusing because players have then to play with how many features? I think it's in the hundreds, where you can tune every single contribution from stacking in this direction or that direction, all multi-loop parameters, etc. I think that the whole count is on the 300 something. The difficulty here is to figure out a way to make that not so overwhelming to the user. So that, okay, I want to tune here a little dial this way and the other one here. What is happening? That's a real complicated one. It's going to look worse than an airplane cockpit, and or I need to be very, very smart in trying to figure out how to make it look good and practical.
You could just limit it and say, you probably have some expectation. These are the 10 most significant ones. The rest ones are just on the edges.
Certainly, yeah, that's a good idea. But essentially, the mechanics are in the engine already, in the game. We need to just make it a little bit more open and accessible.
I think also to clarify, the mechanics, which I think is in principle could be deployed, in the next, within a week, is through the Eterna script interface. So, which is not, super user friendly. It's not, it's not a user like a puzzle. You wouldn't see a literal cockpit where you could turn all the dials. But then again, I think the folks who are most interested in the energetic model would welcome having that kind of control. So I'm actually curious for the real aficionados. We have some of them here in the audience, like Broad and others, and who designed, I think, the puzzle that hoglahoo solved. I mean, what do you think? Would you be interested in spending time through Eternascript, or would you be like, nah, no, I'd rather, I'll wait till there's a cockpit to mess with energy parameters?
I don't know. Possibly. It's just I'm not really into scripting right now. My undergraduate work is pretty much all I have time to be dedicated to.
Okay, that's a fair thing. Okay. Mm-hmm.
Sounds like a good lab design feature.
If there's not anything else, then we can go to lunch. Any more questions? Any more statements from anybody?
I'd like to bring up one more question for Hoglahoo. I'm curious if, in regards to your engagement with lab work, and as far as because this whole immediate feedback thing is really important just for games particularly, because a lot of people generally kind of really want to be able to be able to get that. What would you think if there was a better interface for actively working on stuff for example, hypotheses in labs, where you're not necessarily seeing the actual results of the puzzles, but you're actively working on coming up with, focusing more on like different concepts or stuff like that, as opposed to the solutions themselves.
The specific idea, I don't know. It sounds interesting. I mean, my general thought is more interface, more features, the better. I mean, as long as people who don't want to see them can hide them or whatever. But I like having more things, and I like having changes. But being able to shoot hypotheses through an interface, yeah, I'd certainly look at it. I always look at everything that comes out. It's fun to see all the different things that we come up to try to make things better. And in lab, that would kind of help with the immediate feedback thing. I think to see changes that you make right there have an immediate effect.
Okay, we're going to take one more question.
Yeah, I was just thinking, you're talking about the immediate feedback and how labs still don't provide that. Can you envision a game that you would like to play? I mean, something that was actually based on real lab results. You wouldn't, since we don't have lab results for every possible mutation, but in terms of kind of guessing, okay, of all these, of the things, of the molecules we do have measurements for, here are the ones that are close. Which way do you think, if you want to improve this molecule, which one of these would you take? That works. I mean, can you envision a fun game that would actually be based on the lab data, but get immediate feedback?
I have to think about that. I've tried to think about that a little bit before. I think that the demand for immediate feedback with lab, it's unreasonable, really. But yet, it's still kind of, it's what I've come to expect through the puzzles, and I get the immediate gratification in the puzzle, and so I just kind of gravitate back to it. So, like these ideas to help, keep people's interest in sticking with all these mutations that you don't see the immediate effect from, to have things that you can do to see immediate effects of, like the interface that was just mentioned, or changing rules, or like the cockpit, other things that keep you involved in it and feel like you're still improving on it and doing things with it, and you can see, oh, I think I'm still improving it. I see things on the screen that are telling me I may be improving it. That's good. That's something that keeps me in lab. But I don't really, I've never thought of,
it's not really there, I don't think.
Yeah, I don't have an answer. I have the complaint. I don't have the solution.